Hello. In this short video, we're going to discuss the difference between copy trait and clone trait in Rust. So, um, let's just start with the copy trait. So, first of all, we all know that traits are sort of interfaces of Rust. They are compile time, and they're zero cost. So, a copy trait is most of the times I'm gonna start from the end of the spectrum, from the end of the um, video and go to the start because I'm gonna first say what are the differences between these two, and then say what are them actually underneath. So the copy trait is just for simpler values. It's implicit most of the times, or I think almost all the times, it's implicit. So you don't say dot copy on something. It's not how it's working. Um, it's cheap most of the times. I mean, when you see you don't see copy because it's cheap. That's the thing. If it was expensive, Rust would have tell you that it is um, not cheap and that is an expensive thing. So you need to know about it, and you cannot re-implement it. You cannot implement copy trait by your own. You cannot do that. You get errors because it's simply just memcopy at the bottom. And it's basically what Rust does when you just pass something as an argument to a function. And you have probably seen that it says Rust says that, oh, you know what, you're passing this as a argument, but this does not implement copy. It's drivable, so actually one of the other things that it's it's drivable. You can drive this from you can drive copy trait for a struct, but you cannot implement it on your own. So basically, copy is for small, simple values, and it's cheap and implicit. And basically, this is how most of the times Rust moves values from one place or to another. Clone trait, on the other hand, is for more complex types. It's explicit. If you want to use clone trait, you need to call .clone method. It's explicit. It might be expensive. It might be, for example, cloning a vector is really expensive because you're basically cloning um, every element into another new vector. So it's basically doubling the memory usage, and also basically a copy of everything bit by bit. Or cloning a hash map or cloning a struct can be expensive. And cloning also can contain any logic, and this is actually really useful because, for example, if you have ever used I'm gonna show you in the code, but if you have ever used clone in RC type or the archetype, use clone as a way for counting the new references. So clone method for counting new references. That is basically how they work underneath. Every time you create an arc, every time you clone it, you just increment the counter. And in here we have a simple example of how we are implementing a clone for a struct. We also can implement copy. I think it does this by default because my struct is really simple, but if you want, you can just say this. Drive copy for this. But I cannot say that, okay, please this. And you see that copy is not something that you can read, right? I mean, clone, yes, it's a trait like any other trait. It has a method, everything looks normal in it. But copy is, and you see it's in the marker module of Rust. So it gives you some idea of what is in here. Actually, we can take a look at close this. We can take a look at other traits that are markers, like sized, or like send, or like sync. These are all traits that Rust compiler itself is going to implement for us, not us as developers. You cannot implement sync, you cannot implement sized, you cannot implement send. These are implemented by Rust compiler when it's possible for it to be implemented. So if your type does not satisfy, for example, sync, and you're doing some multi-threaded programming, you probably need to look for other problems. You cannot implement sync by your own or send by your own. So yes, that is pretty it for this video. If you like this content and you want me to continue with this stuff, please like and subscribe, and also follow the channel, do the little alarm thing to get notifications, and please like this video, and until the next video, goodbye.